The Millau Viaduct, or Viaduct de Millau, is a multi-span cable-stayed bridge completed in 2004 across the George Valley of the River Tyne near Millau in the Auvergne department in the Occitanie region in southern France. Supported by 7 towering piers and anchored to the Grateful Tower, the roadway spans more than 8,000 feet over the river valley. The road with the 2 lanes on each side will across the river at 270 meters above the ground. The bridge is part of the A75 motorway and the faster connection between Paris and the Mediterranean. The Millau Viaduct is the world's tallest bridge. At its highest, the structure reached 1,125 feet or 342 meters, about 90 meters taller than Eiffel Tower. Designed by British architect Norman Foster and French bridges engineer Michael Viaduct, the bridge was built from 2001 until 2004, an impressively rapid rate for such a complex structure. When it's open to the public, it was lauded for its elegant design as well as structural integrity and lifespan. The Millau Viaduct was built to help tourists get to their destination, but the bridge may just become a destination itself.
Next, we talk about the main element and material of Millau Viaduct Bridge. They have 4 elements. First one is abutment. They have 2, which is CO and CA. The concrete was poured in several stages because a different foundation are used. The CO the close to the plateau station and house equipment necessary for the operation bridge. For the pier, they have 7 piers for this bridge. They shape that pier rigidity to allow the deck to expand during the temperature change and have a different thickness with shape like octagon with variation in both flanges. For the bridge deck is provided with longitudinal stiffeners to support the bottom flange and top prevent from shear lag, and it is necessary to divide deck into the multi-section. Lastly, the pylon and cable. The leg of the pylon, which are 38 meters high, are composed of 2 stiffened metal box girders and surmounted by a mast 49 meters high, into which cables are anchored. The choice of material for deck and the pylon is actually of metal are made of steel of grade S355 and S460. Next, pier is constructed in B60 concrete because it more durability, and others concrete element of the structure is made of B35 concrete.
Next, we move to the method of construction, where it will divide it into 3 stages. The first stage is site preparation, in which the team has found out that there are 3 different types of rock foundation. The first one is Balayokian dolomitic limestone, the second is compacted marls, and lastly is Hettinger limestone. Then, onto the foundation, where the foundation system for each of the 7 piers is made of 4 reinforced concrete piles with diameter of 5 meters and a depth of 10 until 50 meters that are drilled into the rock. The construction of this bridge has the worksite facilities that are divided into 4 zones, totaling approximately of 8 hectares, and the prefabrication of deck and pylon has reduced the amount of land required for the viaduct's construction. The second stage is on the construction of pier. The pier is constructed by pouring concrete into a temporary mold and is filled with a frame of steel reinforcing bars totaling of 16,000 tons. The GPS system uses signals from multiple satellites, so these pier's construction teams can determine their position and make sure that they are on target for critical points in the sky. Furthermore, the installation of the deck by successive launching operation requires the erection of 7 temporary piers. Each temporary pier has a metal trimmer at the top to receive the launching supports known as translator, as well as the work platform.
Next is the construction of the deck. There are 2 phases. The first is the fabrication of the deck. The Eiffel Tower company has designed the the cross-sectional profile of the deck, they also take account of the possibility of prefabrication in the factory, transport, on-site assembly and launching. The steel element of the bridge were fabricated in factory and only transport to the site for assembling and launching using prefabrication method. Second, assembly of the deck on site. There are 2 on-site factories would set up on the platform with all necessary equipment behind each abutment, such as crane, 90-ton material handling gantries, welding and shops. Next is the cable. The 11 pairs of cable which support each span arranged in a single plane in a half fan pattern. They are anchored along the axis of central reservation at regular interval of 12.51 meter following curvature of the structure. The cable anchor are adjustable at the deck and fixed on the pylon. Now, the last one is the pylon. The pylon are set into the deck longitudinally. Continued is to ensure between the metal sheet of the webs of the central box girder and those of the walls of the pylon's leg. At the start of the launching operation, the partial stake pylon was positioned at the end of each deck length to avoid the deck bending when launched between one pier to the next.
Next is challenges. The first one is wind speed. The wind velocity turned into 100 km per hour drastically and extra than the wind velocity that could ever determine on the floor level. This problem at the bridge due to the fact that the excessive wind speed could push the motors to the side and make it dangerous. 2 is environmental issue. The environmental are the geotechnical troubles of making bridge into 2. The way to maintain the constructive environment across the city. The difficulty crossing the Tarn River changed into resolving putting the pillars close to the river because of the softness of the floor basis across the river. The third one is loads and sun. The capacity of mule loads to fight problems surrounding publicity in each car and the bridge itself to excessive wind and extreme summertime season sun. And for the adoption of advanced technology to protect the environment, first is PC precision software for cranes. Cranes are used in maximum creation on sites. This can bring better payloads and automatic given the development in robotic and PC precision software. Second is transportation. Transportation today will also be a great deal quicker and simpler. Heavy reliance on technology which make it simpler with computerized several development processes. International global warming and are consequently towards the less of carbon footprint at some stage. Lastly is the GPS and laser steering structures. The new technology with hydraulic telescopic equipment, GPS and laser steering structure all deployed successfully to cope with load of technical challenges.
In conclusion, the construction of Millau Viaduct construction presents some of the most advanced system and method of the construction. It is because of due to the complexity of the site, position of the pylon which would sit on the Tarn Valley and the technical difficulties. Not just that, the bridge's construction began at the time of considerable advancement in construction technology. But within the power tool and advanced technology, it can be handled in smooth way, reduce time and cost effective. The construction also accounted to the wind in the valley given the bridge's placement high above the valley. However, with applying the knowledge of the effect of the wind on the structure, study and trial, and took into consideration safety measure by applying extreme conditions on the bridges when under construction and during its time in service, the construction of the bridge were running with smooth and success. That's all from us. Thank you for watching this video. Assalamualaikum until we meet again.